In this video, I will show you how to use the effective index mode solver to solve the modes of channel waveguides. So first, open your web browser, connect to internet, and then go to computationalphotonics.eu. Click enter. It will bring you to this site. The effective index mode solver is here, EIMS. So just click the icon here and it will bring you to the program. Here is how you define your waveguides. This box represents segment of the waveguide. Let's say we have just 2 interior layers and 1 slice. So we have, let's say, 12 boxes to fill in. This box will represent refractive index of parts of our waveguide, segment of our waveguide. Let's say I just need to have 1 interior layer, so I will show you how to calculate for the simple RIP waveguide. So this is the refractive index. Oh no, just 2. Yeah? This is the refractive index distribution, and this is the thickness of every layers, the width of every slice. And here you can fill in the wavelength. Let's say we have waveguide with refractive index of the core, RIP waveguide of the core, refractive index of 2. And we put that onto a substrate of refractive index of 1.5. And the cover is all air, refractive index of 1, 1, 1, 1. You can change it, of course. And let's say the thickness of the RIP, let's say it is 2 micrometer. The thickness of the planar section of the RIP is, let's say, 1 micrometer. The width of the waveguide, let's say it is just 2 micrometer. Let's calculate that for wavelength of 1.55 micrometer. You can change it, of course. We would like to see the result for TE polarization. Just solve it. So it will give us this waveguide is multi-mode. It has how many modes? Many TE modes. We can plot the field profile, let's say, for TE00, the fundamental modes. It will look like this. TE10, it will look like this. This is the absolute value. If you want to see not the absolute value, you can just click this one and then plot again. You will see one part is positive, the other part is negative. So the field profile is something shaped like antisymmetric profiles. We can also see for, let's say, this one, 2 TE21, and it will show the mode has 1 time it crossing 0 in if we move in horizontal direction. So this is dictate the quantum number 1 here, and 2 times it cross 0 in vertical direction. It dictates the quantum number 2 here. We can do the same for TM polarization. It will give us the modes, the effective index, and the values of the beta. We also can plot, let's say, TM20. It looks like this. If you don't want to plot the absolute value, just replot by clicking this one, and you will see positive, negative, positive. So the wave, it is waving inside the core. So the rib, yeah, inside the core of the rib waveguide. Of course, you can also extend your waveguide, let's say, to include three slices, so you can make your waveguide to be, let's say, one, 1.5, 1.5. So your waveguide now has two ribs close to each other. So it is called directional coupler structure. You will see, oh, it supports many modes, but because the index contrast is quite high. So if we decrease the index contrast, you will see the number of the modes will also decrease, because the V number is decreased because the index contrast is smaller. V number will depend on parameter like index contrast, and then thickness, and then refractive index, and also wavelength. Now your waveguide only have 4 modes. If we further make the rib to be thinner, it will have less modes. It has 2 modes, TE, TM0000, and TM01. We can plot, and we see like this. If we click this one, you will see it is anti-symmetric mode. We can plot this one, and it will give us symmetric mode. So we have 2 modes waveguide, 2 modes coupled waveguides. One is symmetric mode, the other is anti-symmetric mode, and the bitting or the superposition between these 2 modes will make us to be able to calculate the coupling length, the length where the light from one waveguide will move completely to the other waveguide. You can also plot the asset, the pointing factor, and it will give you this one. Okay, I think this concludes my demonstration on how to use the effective index method mode solver. Thank you.